So let me introduce our first speaker. He's a fellow Nokian just like me, Michał Pawlik. Michał is a site reliability engineer at Nokia. He has over 6 years of professional experience and has been an author for Programmista magazine. He's an advocate of Scala programming language and functional programming, studied at Wrocław University of Technology. His friends say that when Michał is done solving problems at work, he solves some more problems and has completed an impressive amount of Wrocław's escape rooms. Today he is going to talk about site reliability engineering. Please give a warm welcome to Michał Pawlik.
Hi everyone, thank you. Yes, today site reliability engineering. I set a few goals for myself for this 15 minutes. I want to introduce the topic, explain the relation between site reliability engineering and DevOps, and also to avoid getting you asleep. So I hope I can achieve one of it at least. So before we get into site reliability engineering, SRE, we're going to start with DevOps. How many of you think it is just a buzzword? Raise your hands. Okay, half of you. It was for me as well. But I thought like, okay, we have this DevOps, people keep talking about it, so maybe there is a sense in that. And I thought like, we engineers tend to work in specific manner. We start up with a problem, then we try to find a solution, make an implementation, deploy it, it might work for us. So I thought DevOps should work like this also. And let's try to find what's the problem behind DevOps. So first of all, I think most of you here are developers. So we had developers doing their job, writing their code, and what was the business expectation from your side? So creating features, fixing bugs, and doing it as fast as possible. So in a unit of time, be it sprint or some sort of unit, you wanted to have as good velocity as possible. But you have to remember that boosting velocity is not very friendly to quality. So since some point you might have lost quality. But this is a goal, you wanted to do it because the business expectation was like that. Then you have the other group, some guys that are taking care of the servers to work all right, that make sure that your service is operable. So the business expectation from the group of system administrators is to have stability. Okay, you want them to take hand on the backups, so in case we have an emergency, we can roll back. And we have found out that there are a couple of problems that take the stability low, that make the unavailabilities. And one of those is, of course, hardware issues, but we have to handle with that. But for me, the most popular one was changing the software, be it changing the configuration or the software version deployments. And while trying to boost the stability, we have found out that we limit the amount of deployments and the production changes because we wanted to have the stability high. And this resulted in conflict. So by setting those strange, from this point of view, expectations, we have conflicted two parties. And right now, instead of developing a product, delivering, we are having internal problems, which is very bad for business, right? We are not earning money, we are trying to solve internal problems. So this is the problem behind DevOps. So let's try to solve it. Let's introduce a culture of mutual awareness, so both parties know what they are trying to achieve, but let's have them work for solving a common problem and achieving common goal, which is reliable service. So instead, like on the previous slide, having two separate goals, let's set up something that's common for them so they will know that they have to cooperate. And then the DevOps is a sort of a culture that has its own postulates. You can read them through here. We will go into them in a second. But this is basically where DevOps ends. So this is something like culture. Okay, you can read in the books somewhere that there are maybe some suggested practices, but nothing really strong. Then what provides real strong practices is site reliability engineering. Basically, a thing that was invented at Google and more than 10 years ago. They thought like, let's take a developer, sit him with the operator's guy, and make them do the operator's job. So let's see what they will come up with, how they will use their development skills to make the operations easier. So basically that's what SRE is. And my claim for today is that site reliability engineering implements the DevOps. Let's try to go through it. So first of all, reducing organizational silos. We have identified that we have 2 silos. Those look perfectly, they are separated. We want to crush them. We don't want silos, we want a cooperation instead of separation. How do we do this? We do this by achieving at least 2 goals. We want to share the production ownership, because we no longer want to have those blamings on, okay, those operators, they haven't managed to keep this system operable. We want both developers and operators to be responsible for the state of production. And we want to have a common approach, common set of practices on how to operate the production environments. So this is the part when SRE tries to develop some sort of practices for you to follow. Then accepting failure as normal, which sounds a little bit controversial at first, because why accept failures? We could avoid them. Well, failures will happen. When you go cycling or doing whatever sports, you have to be prepared that you will eventually break your leg or something, and you have to buy insurance for that. So what's our insurance in this case? Well, this is very clever. We introduced something that we call service level objective. Basically, we claim that in a certain unit of time, for example, a month or maybe a quarter, we will have our service available for 99% of this time. So what about the lasting 1%? Well, this is an error budget. So this is the time you can invest in playing with production, deploying new version of software. Be my guest. If you want to shut down the production for an hour, as long as you don't exceed this error budget, do it. This is completely fine. So this way, we have this common sense that we can do something on production, we can break it for some time. And then, very, very important practice that made me learn a lot, this is post-mortem culture. So in case something goes wrong, and as I said, it will, you want to write a document on how you investigated, how have you found out what was the root cause, how have you fixed it, and how to avoid it in future. So you write a document, it's best if you do it live when fixing, and then you want this document to be blameless. This is the most important word regarding this document, because when you start pointing fingers, looking for person responsible to punish them, they won't write such documentation anymore. They won't be able to cooperate in this manner. So being blameless is the core of such documents, and believe me, it helped me many times to improve my my work. My friends can agree with me. Okay, so let's move on. Now, implementing gradual change. So every time you are facing any hill, for example, you prefer to go with the stairs or with a ladder instead of jumping, because you can hurt yourself doing something like that. So I can see no reason for doing it otherwise in software development. So if we have to choose between large changes and very small ones, let's take the ladder. Let's go with the small ones, because every time you do something wrong, you're able to quickly go down, identify the change that was responsible for the fault. It is simpler. And one of the practices that is popular, especially in the large products like Facebook, like YouTube, are canary releases. So very small ones that are deployed for 30, maybe 10 or 30% of your audience, of your clients, and measuring how does it behave. If it makes application crash for them, you can roll back. And if it doesn't, you just proceed with that. Now, leveraging tooling automation. So you have a team that has very wide skill set, because you have the operators and the developers. They can build, and then they can use the tools for automating their daily tasks. One of the biggest words in this is infrastructure as a code. So instead of installing the operating system, creating users, installing the software, you simply want to write a program and then launch it every time you need another instance, so you can scale better, and you also eliminate the manual work, which is error-prone, like repeating manual steps. It is very error-prone. And then the last but not the least, measure everything. And by everything, I mean everything. Not only the servers, like you want to know if you're running out of the disk space or if your services are healthy. This is very important. You don't want to be the last one to get to know that the service is off. You don't want your client to call you in the middle of the day. Hey, I think the service you provide is down because I can see the website. You want to be the first one to know it and to react. But the also very important thing that you have to measure is your work. So how much work do you perform manually, and what are the key areas that you can improve, that you can leverage the automation there to have more time to do the real job and not to produce the toil. So basically, in this short slides, I could prove that site reliability engineering solves everything that DevOps suggests. And my claim is that site reliability engineering is actually a superset of DevOps. So it doesn't only solve what DevOps was the original problem for, but also introduces very wise techniques of developing software. And there are many resources you can read about. We don't have many time left for that to explain. I want you to remember that site reliability engineering teams are more or less half dev, half ops, which makes them strong, which makes them have this skill set and this knowledge. They can then cooperate with other teams. And what's very important, I believe, is that it is proven to work. So Google never left this idea. They still operate their large ecosystem like this. Many other companies have adapted this. You can see many job announcements and stuff like that for SRE. It is also proven to work for my team. We are working in this manner for over a year and very happy about this. And I can see no reason that those practices wouldn't work for you. Thank you for your attention. Some resource materials for you in case you want to further reading.
Thank you, Michał. I think we can take one quick question if anyone has. I think you can speak without microphone.
You can use different tools. For us, it is Munin, Zabbix, and we also wrote some our internal tools for checking the health of the systems. But you also can use something more popular right now, like Prometheus, stuff like that. Actually, whatever suits you and whatever is best for your use case.
Thank you. One more applause for Michał.
Thank you.